Hello students, this is Professor Chalai, and in this video we're going to look at deriving molecular formulas. By the end of this video, you should be able to calculate molecular formulas from empirical formulas, and if we couple that with what we've learned in our previous video, it means that you should be able to also calculate the molecular formulas from the masses of the elements and the percent composition of each of the elements. As always, you can follow along with our chapter worksheets. Now, just as a quick reminder, in our previous video, we looked at how do we derive the empirical formulas from compounds. And as a reminder, let's look at a molecule like H2O2, which is what we would call the molecular formula. The empirical formula is simply the smallest whole number ratio between each of the elements, and in this case, it would be H1O1 or just HO, which would be the empirical formula. In our previous video, we learned how to figure out what this empirical formula was given certain experimental data, like the mass or the mass percent composition. Now we're going to figure out how to go from this empirical formula to the full molecular formula. And to do this, there's one crucial piece of information that we need, which is the molar mass of the molecule. So if we have the empirical formula and we have the molar mass, we can go ahead and calculate the molecular formula. By using these steps right here, we just multiply it by the molar mass divided by the empirical formula mass. And I'll show you what I mean by that by doing number 19. So let's look at number 19. In number 19, it says that we have some compound with empirical formula CH2O. They give us the molar mass of the compound, and so they're asking us for the molecular formula for this compound. So let's look at it. We know that the molecular formula is just the empirical formula. So let's see H, so that's C1, H2O1. I'm just putting the 1 here now to remind ourselves that that's actually a 1 right there. Multiplied by the molar mass of the molecule divided by the formula mass of the empirical formula. So we have the molar mass of the molecule right there. It's given it to us in the question. So we need to just figure out what the empirical formula mass is. This is the empirical formula. What is the formula mass for this? Well, we have 1 carbon, so it's 1 times 12.01 grams per mole. Plus we have 2 hydrogens, so it's 2 times 1.01 grams per mole for hydrogen. Plus we have 1 oxygen, so that's 1 times 16.00 grams per mole. And the formula mass in this example comes out to be 30.03 grams per mole. So let's plug this in. So this means that we have our empirical formula C1H2O1 times the molar mass of the full compound, in this case it's 180 grams per mole, divided by the empirical formula mass, 30.03 grams per mole. Of course, in this example, the grams per mole will cancel out, so we don't have a unit. All right, 180 divided by 30. If I plug these into my calculator, I get a number like 5.994, which is very close to 6. And since we can only multiply by whole numbers, let's just use 6. So this formula multiplied by 6 gives us a molecular formula of C. 1 times 6 is 6. H2 times 6 is H12. And O1 times 6 is O6. And so that's it. This is our molecular formula. Let's think about what happens here when we multiply by this factor. All we're saying is the formula mass and the molar mass of the full molecule is related by some whole number, and we're just figuring out what that whole number is and then multiply each of these numbers by that to get the full molecular formula. And that's it. That's how we go from an empirical formula to a full molecular formula, by using the molar mass of the whole compound and the formula mass of the empirical formula. Let's see if you can try number 20 on your own. It combines the things you've learned in the last lecture of calculating the empirical formulas and the things you've learned in this lecture by calculating the molecular formula from the empirical formula. Pause the video, and when you're done, you can unpause and we'll see where we get. Okay, so let's look at nicotine. It says it has carbon, hydrogen, and nitrogen. So it has a formula CHN, right? Alphabetically. X, Y, Z that we need to figure out. And then once we figure out the empirical formula, we can then calculate using the molar mass information, the molecular formula. So let's do this one step at a time. The first step would be to figure out what the empirical formula is. All right, let's look at carbon first. We have 74.02% carbon. If we apply this to 100 grams fictitious mass, we will end up with 74.02 grams of carbon. Divided by the molar mass of carbon gives us the number of moles of carbon, in this case 6.163 moles. Let's look at hydrogen. We have 8.710% applied to some fictitious mass gives us 8710 grams. Now, usually I've been using 1.01 grams per mole for hydrogen, but you never want to use a number that will reduce the number of sig figs that you have. And if you look at your periodic table, the molar mass of hydrogen is actually 1.00794, and it actually continues. I usually use 1.01 because I rounded to this decimal place, but that will give us 3 sig figs in our problems, which we don't want. So I'll round it to this significant figure instead, and so that'll be 1.008 grams per mole. And that way I can keep 4 significant figures in my answer. So if I do that, I end up with 8.641 moles of hydrogen. Okay, now let's look at nitrogen. So for nitrogen, we have 17.27 grams divided by 14.01 grams per mole, which gives us 1.233 moles of nitrogen. We're still trying to figure out what the empirical formula is first, so let's write our pseudo formula. Carbon 6.163, hydrogen 8.641, and nitrogen 1.233. We divide by smallest number. In this case, the smallest number is 1.233, so divide everything by 1.233. And that will give us, for carbon, it gives us something like 4.998, which is close enough to 5, so we'll call it just 5. For hydrogen, we get 7.008. Again, that's close enough to 7, so let's just call it 7. And then for nitrogen, we get 1, right? 1.233 divided by 1.233 is 1. So here, what we end up having is now the empirical formula. Okay, now we need to figure out what the molecular formula is. So we can multiply all of this by the molar mass of the molecule divided by the formula mass of the empirical formula. So we need to figure out each of these. Well, here it says that 40.57 grams of nicotine has 0.25 moles. Grams of nicotine, moles of nicotine, we can figure out the molar mass, right? So the molar mass of nicotine is equal to 40.57 grams has 0.2500 moles, which means that it comes out to about 163.0 grams per mole. Okay, so this is 163.0 grams per mole. Let's figure out the formula mass from the empirical formula. All right, well, we have 5 times carbon, right, plus 7 times hydrogen, grams per mole, plus 1 times nitrogen, which gives us an empirical formula mass of about 81.13 grams per mole. So instead of this, we have 81.13 grams per mole. As always, the grams per mole will cancel out. And if we do our math just for this part, we end up with a number that looks like, let's see, that looks like 2. A number close to 2. So to get from the empirical formula to the molecular formula, we just need to multiply all of these numbers by 2. And so that gives us 5 times 2. That's 10, so C10. H is 7, so 7 times 2 is 14. And N is 1, so 1 times 2 is 2. And this is our molecular formula. I hope every one of you got this correct. If not, you can always check back this video, send me a message, and we can see where you got wrong. But the first step is to use all of the information that we have to figure out the empirical formula, and then using the molar mass and the formula mass of the empirical formula to figure out the molecular formula. I'll see you in the next video where we talk about combustion analysis. Here's where you're going to have practice to do a lot more kinds of questions, a lot more practice on the types of questions that we just did previously. I'll see you then. Bye.